Hey, it's Dr. J. 2.2 linear equations today. We have two main objectives. We're going to talk about equations in one variable and in two variables. So let's get started. Perhaps the best way to define a linear equation is not by what it is, but by what it is not. So the definition of a linear equation does not have any of the following. In other words, if you see any of the following, that means that it's not a linear equation. So it does not have exponents or powers other than 1. So you'll never see an exponent other than 1. You will never see variables, in other words, letters, in the denominator. Yeah, so if you see something like, a variable in the denominator, that is not a linear equation. Yeah. If you see an exponent other than 1, like x squared or something like that, that would not be a linear equation. It also doesn't have any radicals, also known as roots, such as a square root or a cube root or something like that. So a linear equation is an equation with letters and numbers, operations, addition, subtraction, multiplication, division, but it will not have any of the following. No exponents other than 1, no variables or letters in the denominator, and no radicals or roots. We'll start off with one variable. A variable is a letter representing an unknown value. Our goal is to find that value. We call that solving the equation. If it's not clear, we sometimes will say what we are solving for. Since this is example 1, I will be very clear. I will say solve for x. Oftentimes we omit the for x part, and if it's obvious what you're solving for, you can just simply say solve. So we'll go ahead and set up a linear equation. So this is a linear equation. You can have addition, subtraction, multiplication, parentheses, variables, and constants, but notice that it does not have any of the following. There are no exponents other than 1. Notice everybody has an exponent of 1, you see. 1s are invisible, so we typically do not write them because it would start to get very cumbersome to have to write a 1 every time you have a variable. And so we oftentimes will just omit the 1. Okay. I want to point a few things out before I actually solve the problem. You always want to work vertically and work from the top down. Try not to move your next step horizontally. I will definitely try not to do that because of the size of my board. I will break that rule only if I get to the bottom of my board or bottom of your page and you have to move over to another page. Then that, of course, would be the exception to the rule. But try to keep your equal sign going straight down from step to step so that each step is clear if you have to go back and check your work or find the solution. Okay, the first thing you want to do is distribute. If you see parentheses, you are going to use the distributive property, and you're going to distribute. So on the left-hand side, we have negative 6x plus 6x minus 2. Yeah, 2 times 3 is 6. 2 times negative 1 is negative 2. Okay. And then on this side, we got to be careful. This is called bait. Don't take it. If you haven't had my class before, you'll get used to the way I talk. When something looks really easy and it looks like it's dangling right in front of your face, it's too good to be true, it's bait. Don't take it, all right? 5 plus 2 is 7. That looks like a very easy step, but it's incorrect. You do not want to add the 5 plus 2. You want to bring down the 5, and you want to distribute the 2, much like we did on the other side of the equation. So your first objective is to get rid of all the parentheses. That's your first step, distributing. If you need a little reminder of that, we call that the distributive property, or sometimes we just say distribute. Some people say distribute. You can say it that way as well. Negative 6x and positive 6x. That is 0x. Yeah, negative 6, positive 6 is 0. In fact, in the next step, I just won't write it. 0x is gone. There are no x's on this side. On this side, we're going to combine the 5 and the negative 6. Those are your like terms. 5 and negative 6 is negative 1. And then bring down the 2x. Okay. In my next step, I do not need to write the 0x. I want to save a little bit of my board space, so I'm just going to erase it. All right, the x's are gone. Now, I need to get all of my variables onto the same side, and I need to get all my constants onto the same side. Well, I already have my variable on this side. Yeah? So I might as well just leave it there. Yeah, and just move my constants to the other side. So in my next step, I'm going to add 1 to both sides. Bring your equal sign down. Negative 2 plus 1 is negative 1 equals 2x. Now I need to isolate the x. I want the x to be alone, isolated. So this really means 2 times x. That's what it means, 2 times x. So to isolate, I'm going to divide by 2. And then 2 divided by 2 is now 1x. Now here I am. I'm at the bottom of my board. So I'm going to move sideways. Actually, I'm going to move. Yeah, I'll go ahead and move this way. This is negative 1/2 equals 1x. Technically, there's an invisible 1 here. 2 divided by 2 is 1. Nobody ever writes the 1. So you just say x equals negative 1/2. This might look backwards to you, so I recommend just flipping it around in the standard order. X equals negative 1/2. And there you go. That would be your solution. If you want to learn a little terminology before I move on, a little bit of terminology. We say x equals negative 1/2 is an equivalent equation. The solution is negative 1/2. So if you want to be the life of your next party, the solution is not x equals negative 1/2. That is an equivalent equation. The solution is just the numeric portion of the answer. the negative 1/2 is technically the solution. Now, I'm not really going to split hairs with you, but I think it's important that as you learn mathematics, you also learn how to say it properly. Okay. Let's go ahead and try another one of those. Actually, I don't want to start there. I got to start at the top, otherwise we're going to end up in a lot of trouble as we move through this problem. So, no. Okay, example 2. Another equation involving fractions. We don't have any parentheses in this example as it sits, but you might have to introduce them at some point to guarantee that you're properly distributing when we do our least common denominator. So first thing I want to point out is you have to look at all of the denominators in the given problem, including the ones that you might not see. So if you see a whole number or an integer, there's an invisible 1. Remember, every whole number, every integer, every natural number has an invisible denominator of 1. So that counts. So our LCD, we can do this with some mental math. LCD is 1 times 2 times 3. So that'll be 6. And again, you probably didn't need to write that down. If these numbers get a little more complicated, I might have a more sophisticated process for finding the LCD, but in this case, it's going to be 6. All right, so we're going to multiply everybody by 6. Remember, numerators only. And so now I have to introduce these parentheses. Multiply everybody by 6. Everybody, even the one that doesn't look like it needs it. You know, people often forget that this term requires a least common denominator of 6. Okay, so we have 3 goes into 6 2 times. So we have 2 times x plus 5. We have 1 goes into 6 6 times. So that's going to stay a 6. 6 times 7. I guess I probably should have just done that. That'll be 42. And then I've got 2 goes into 6 3 times. Or you can say 6 divided by 2 is 3. And then now you've got 3 times x minus 6. And so I had to introduce these parentheses to make sure I don't screw up the distributive property. Or to make sure that I distribute properly. So there's my distributive property. Got 2x plus 10 minus 42 equals 3x minus 18. And now we're good to go. There are no more fractions. This problem just looks like an ordinary equation that we've solved in the past. Let's combine like terms first. Looks like we've got a positive 10 and a negative 42. So combine. That'll be negative 32. Notice how I move directly down. I try to keep my equal signs relatively lined up. I don't kind of get off to the side unless it's absolutely necessary, if I run out of space or something like that. All right, we're almost done. All we're going to do is get all our x's onto one side. So let's subtract 3x from both sides. Or sometimes I'll say add negative 3x. Yeah, it's the same thing. Right, and now I'm going to add 32 to both sides. So I have negative 1x is equal to, what is that, 14? 18, 32, 14? Yeah. Positive, make sure you get the right sign. So 32 minus 18 is 14. Now I'm going to have to break my little rule here and just move over sideways because it's necessary. I'm kind of out of space down at the bottom. So I've got negative 1x equals 14. So I'll divide both sides by -1. And my answer, my solution is -14. Or my equivalent equation is x equals -14. My solution is -14. And we'll just leave it like that. Okay. If we really wanted to make sure I could plug this back into the original problem and check, we'll get to that later. We're only on example 2, and if I start doing that now, we'll never get through this video. So I'm going to just go ahead and leave it like that. That one's done. We'll move on to example 3. Solving for a different variable, which I'm going to call y in this example. So I got 2/3, parentheses y minus 4. Sometimes we call this the quantity y minus 4. So 2/3 times the quantity y minus 4 plus y is equal to 3/4. Let's do our LCD bubble here. LCD, again, there's an invisible 1. If you don't see a denominator, there's an invisible 1. So the LCD of 3, 1, and 4. Most of these you can do with mental math. What's the smallest number that's divisible by 3, also divisible by 4, and divisible by 1? Remember, every number is divisible by 1. So it's really the 3 and the 4 that matter. And that would be 12. Yeah? 12 is the smallest number divisible by all of these denominators. So we're going to multiply everybody by 12. Make sure you hit only the numerators. Do not multiply the denominators. That's a very common mistake. Not only is it a common mistake, but that's a technique that's sometimes taught in pre-algebra. And then by the time you get to algebra, it's not done that way. And students go, oh, what the heck? That's not the way I learned it. Well, that's welcome to math, okay? So what are we going to do here? You have several ways to resolve this. You can go 12 divided by 3 times 2. So you can keep that in your head. 12 divided by 3 is 4. 4 times 2 is 8. Okay, you can do it that way. Or you can go like this. 12 times 2 divided by 3. 12 times 2 is 24. 24 divided by 3 is still 8. So I say that, I call that any way you slice it. Any way you slice it, that's going to come out to be 8. Yeah. Here you have 12 divided by 1, which is just 12, and then times y. So that's 12y. Okay. And on this side, you have 12 times 3, which is 36. 36 divided by 4 is 9. Try it the other way. 12 divided by 4 is 3, and 3 times 3 is still 9. So again, any way you slice it, you're going to get 9 there. Oh, and now you've got to resolve the parentheses. So use the distributive property. 8y minus 32 plus 12y is equal to 9. I don't have a very difficult decision to make because all of my y's are on the same side, right? So it's like, life gives you lemons, so everything is already here. So I've got 8y and 12y. I'm going to combine those together. That's going to be 20y, and then minus 32 equals 9. Okay. I'm trying to get my y all by itself, so I'm going to add 32 to both sides. Again, I got to the bottom of my page or the bottom of my board. I'm moving over sideways. So now I've got 20y is equal to 41. And my last step is to divide by 20 to get the y by itself. Reduce this if possible. Another word for reducing is simplifying if possible. Notice I'm not doing it because it's not possible. But your example could be possible. For example, if it was 40 divided by 20, yeah, that would be reducible. Even 42 divided by 20 would have been reducible. You want a quick 1 second review of a reducible fraction. If the numerator and the denominator have a common factor, then it's reducible. These have no common factor, so we are done. That's the answer. In this particular section, I'm going to avoid the calculator, so I'm not going to give decimal answers. I'm just going to give reduced or simplified expressions, and that's the best way to leave it. Yeah. Turns out if you put this into a calculator, you might not like what you get. It's still true, it just takes up a lot of space. How about decimals? You like decimals? They're kind of like fractions, but decimals. The variable's t. T is a very common letter that we use in mathematics, especially when we get into the next section. So I'm kind of peeking into the next section. We'll start doing word problems. I often use t when I'm talking about time. It just makes a better variable than x. Be careful the way you write it. Notice if you write your t's like that, they kind of look like plus signs, and it can get very confusing. So I like to write my t's with a little hook at the bottom of them so that I can tell that they're not plus signs. One technique that I encourage you to use is just to call it x. I mean, some students are just like, why not just call it x? You certainly are allowed to do that. I would never mark something wrong if you solved it correctly and you called it x and I called it t. Doesn't matter. You're going to get the same result anyway. Remember, the solution is independent of the variable anyway. Right? So if I get t equals 5 as my answer and you get x equals 5, well, we both have the same solution. The solution is 5. So just keep that in mind. I'm going to go ahead and use t because I've already written it down. No parentheses, so we can skip the distributive property. All right. Now, these might look like decimals, but they are actually fractions. All right. Every decimal, every whole number is actually a fraction. You just count the number of decimal places. If there are no decimal places, it's a fraction of 1. So 2 divided by 1. If there are 2 decimal places, it's 100th. All right, 100th. Not 100, but 100th. It's in the denominator. If there's 1 decimal place, it's a 10th. So that's 5/10. And again, if there's 2 decimal places, it's a 100th. So 1.51 really means 151 hundredths. Yeah. So the LCD with decimals is very easy. It's always the largest denominator. That's why people like decimals. Because decimals, if you see a denominator, whichever one of these is the largest, that's automatically the LCD. It's typically either 100 or sometimes it's 1,000. Very rarely it will be 10. But I mean, if 10 happens to be the largest denominator in that problem, well then the LCD would be 10. It's rarely ever 1. Because if the LCD was 1, well then that means there's no real decimals in the problem, right? So in this problem, it's 100. So we are going to multiply all of our fractions by 100. Okay. So now we have 100 times 2 divided by 1. That's 200t. We've got 100 times 46 divided by 100. That's just 46. It's 4,600 divided by 100, which is 46. Bring down your equal sign. 500, 100 times 5, 500 divided by 10. That's 50. Yeah. And then 151 times 100 is 15,100. And then divided by 100 is 151. Now, when you were little, like 10 or 11 years old, you probably learned a little trick where you just move the decimal over a couple places. That trick's fine, but most people learn that trick when they're 10 years old or 11 years old, and then by the time you get to be 20 or 30, you don't remember which way do you move it. Do you move them all the same amount? Do you move this one 1, this one 2, this one 3? So I don't teach the 4th, 5th grade rule of moving the decimal over, okay? That's just not the way I do it. I do it the algebraic way. This is college algebra. I want you to do it the algebraic way. Now, I'll tell you this. If you still remember the 4th, 5th grade rule and you do it correctly every single time, that's fine. That's great. But this is the college algebra way to do it, okay? I would call it the proper way to do it, but it turns out they're both correct. Just this is a different perspective. Same result. So what are we trying to do? Let's get back to our goal here. Notice this equation looks very much like all the other equations that we've had. This equation has a variable of t, no big deal, same thing. I'm going to move my t's to the left-hand side. So I'm subtracting 50t from both sides. Your other option would have been to add negative 200, subtract 200t onto the other side. You could have done that as well. Okay. So I've got 150t plus 46 equals 151. Now I got to move the 46. So subtract 46. I just draw these lines to sort of keep myself, lined up, as they say. This is canceled out. 151 and negative 46 is 105. I've again come to the end of my rope here. End of my rope. So I'm moving over. 150t equals 105. Dividing both sides by 150. And now this is where the reduce if possible comes in. Yeah. Last time we got lucky. They didn't have anything in common. All right. So if these have nothing in common, then you can stop. All right. But in this case, you cannot stop. They're both divisible by 5. Yeah. 105 is 5 times 21. If you don't believe me, times it out, multiply it out. 5 times 20 is 100. So 5 times 21 is 105. And 5 times 30 is 150. Okay? So you can eliminate or cancel out a pair of 5s. So now you have 21 over 30. Can you stop? No! 21 and 30 are both divisible by 3. So you have 3 times 7 and 3 times 10. So you have 7/10. All right. Now remember, the problem was a decimal. So my solution is 7/10. I'm not using a calculator, but if the problem is given as a decimal, then you can answer it as a decimal. So you can just say 0.7, 0.7, or 7/10. So notice the way I do it. I take a decimal. I turn it into a fraction. I solve it. I take my fraction. I turn it back into a decimal. At no time did I ever have to plug it into a calculator. All right. Now, you have a calculator, so use it if you have to. But the intended method is that it's not necessary to use the calculator. Okay, so that about does it for the one variable equations. Next, I want to teach a little bit of vocabulary, more terminology before we move on to the two variable problems. So before we move on to two variables, we must learn some vocabulary. So all linear equations essentially follow the same set of rules, the same set of steps. The solutions often come out different, but the way that you do it and the way they appear in the homework and in the tests and stuff, they all kind of look the same, right? And so we want to learn some vocabulary so that we can kind of figure out which ones go into what category and which problems have different types of solutions. So there are three types of linear equations. And we're talking about one variable, of course. I haven't started the two variable yet. The first type is the most common. It's called a conditional equation. All of the examples that I've done in this lecture have been conditional. Yeah, so all examples done so far. So every problem that we've done so far have all been conditional because each problem gave us one solution. Yeah. But we're about to see some other types of equations. The next two types are called identities and contradictions. Identities have an infinite number of solutions. Infinite number or infinitely many solutions. We will see one in a minute. Okay. This comes from the word identical. Yeah. So if both sides of the equal sign are identical. So if I gave you an equation and said, x plus 5 equals x plus 5. That's identical. Identity, you wouldn't even have to solve it. Infinitely many solutions. And then finally, the worst possibility would be a contradiction. That would be a problem with no solution. Yeah, this would be an equation that's always false. It is never true. Yeah. An example of that would be x plus 5 equals x plus 3. That's never true. X plus 5 is never, ever going to be equal to x plus 3. Although you could try. You could try to solve this. You could spend a bunch of your time trying to solve it, but whatever you get is nonsense because this equation is always false. All right. We call this classification. Classification. So you're classifying the equation. All right. These are called the types, conditional, identity, contradiction, and these are the number of solutions. And they are all linear equations. These are all classifications of linear equations. So essentially, if you want to think a little bit abstractly about it, we're taking a bunch of equations that all kind of look the same, and we're putting them into 3 different classes based on their number of solutions and their type. Want to see some? I'm sure you do. Yeah, I'm sure you can't wait. Now, we're going to do several of these. I'm sort of getting blurry on it. Let's see if we can get this to come back down. We're going to do several of these problems, so we'll just do one at a time, but I'm going to put them all into the same category here. Just got to give my camera a second to, come on back down to me. Come on. Here, maybe it'll just catch what we do. So we'll call this A. I'm trying to wait for it to get unblurred. All right, come on. Come on. Come on. Come on back down. Come on down, focus. There we go, good. All right, so classify each equation. I only have room to do one at a time, so we'll call this A. All right. And notice when you first look at it, it's difficult to tell. I mean, you can tell it's linear. That's about it. I mean, you can't really tell anything else from it. So what you do is you just start trying to solve it, and then you stop once you understand what class it lies in. I don't really care about the answer. I just want to know what class it lies in. So we're going to go ahead and distribute. Notice the right-hand side is already done for us, so I'm just working on the left-hand side. So I get 10x plus 5. Nope, excuse me. 10x plus 25. 5 times 2 is 10. X. 5 times 5 is 25. And then I get 10x plus 30. 10x plus 30. There's nothing to do on the right-hand side, so I just leave the right-hand side alone. Keep on going until you can tell what class it's in. Keep going. So now you're going to combine like terms. Combine like terms. So I've got 10x and 10x. That's 20x. 20x. And then I've got, I could kill 2 birds with 1 stone here. I've got 25 and 30, so I've got 55. All right. So now, are they identical? No, they're not, right? They're close, but they're not identical. So this would be not an identity. All right. So you know it's not an identity. So now we've narrowed it down. It's either going to be conditional or it's going to be a contradiction. All right. Now a contradiction is easy to spot because it makes no sense. All right. A contradiction is a false statement. All right. Does 20x plus 55 equal 20x plus 58? No, it's always false. Now you might not see that right now. Sometimes it's hard for people to see the lie. Right? Somebody could just be lying right to you and you don't see it. So take it down one more step and tell me if you see the lie then. Most of you will see it. If you don't see it now, you're going to see it in a minute. Watch. Subtract 20x from both sides. And now you can clearly see that this statement is always false. 55 is equal to 58? Look what happened. All of your x's are gone. 20x minus 20x is no x's. And over here you have no x's, so you just have 55 equals 58. This is always false. So a statement that's always false is a contradiction. It has no solutions. We're done. That's it. There is no solution. I give up. We're just going to continue with this with just another example. I need to just call this one part B, I guess. So we'll just call this part B. And again, I mean, unless you have really good mathematical eyes and you can see the future, it's very hard to tell. Honestly, I can barely tell. I'll be honest with you, I only know because I already did this problem. I mean, had I not already done this problem, I wouldn't know either. All right, so you have to kind of dig into it a little bit, you know, and see what class it's in, right? And that's kind of true. And if you want to know something about something or somebody, ask them a question. You're going to know in 5 minutes what class they're in, right? So 4 times 5 is 20x. 4 times 4 is 16. Bring down the plus 2. We'll do that in the next step. 2 times 10 is 20x. That's getting 20x again. 2 times 9 is 18. Can you see it now? If not, go one more step. Take as many steps as it takes you. I bet you can see it now. Look, 16 and 2 is 18. So now we have 20x plus 18 equals 20x plus 18. Both sides are identical. So it's an identity. That's the easiest one to spot. Identity has infinitely many solutions. Infinitely many solutions. Yeah. We're not using the infinity symbol yet, so I won't accept the symbol for infinity. I want you to actually write that in your notes. On the homework, it's multiple choice, so just choose the one that says infinity or infinitely many or something to that effect, okay? At this point in the semester, I'm more interested in exposing you to the idea than I am about, you know, being picky about how you spell it or how you type it or anything like that. That's the least of my worries at this point. We'll get to that later. I mean, there will come a day where we will use the infinity symbol, and I will be very picky about how you do it, but today is not that day. Okay, this is still what I call the honeymoon, so it's all good. No worries, as they say. Might as well do one more. I mean, you can probably guess what the next one's going to be based on, you know, prediction. But let's go ahead and do one. See if I got another one here. 6 times 5x plus 6 plus 7 is equal to 29x plus 44. And again, it's difficult to see what it is until you do it. Yeah. So go ahead and distribute. Only got one set of parentheses. So that's 30x plus 36 plus 7 equals 29x plus 44. It's not identical. Yeah. Notice if the x's are different, you know it's not going to be identical. 36 plus 7 is 43. 29x plus 44. It's interesting, but it's not identical. Look at that's a 43, that's a 44. You know, that's a 30, that's a 29. So it's not identical. All right. Let's see if it's a contradiction. That's what I recommend. Start, is it identical? If not, is it a lie? Is it always false? And if neither one of those, then the third category is the conditional. Let's see. We're going to move the 29x over. So now we just have 1x. Notice we actually have 1x left. 29, 30 take away 29 is 1x. Some people actually put the 1. I don't, unless I'm really trying to prove a point. Bring down the 44. That's not a lie. Yeah. If there was no x, then it would be a contradiction, but we have an x, so this is going to be conditional. Might as well go ahead and finish it. X is equal to 1, so this is conditional. There is one solution. All right. It happens to be the number 1, but I mean any number, x equals 5, x equals 12, even x equals 0 is still 1. That's still considered one solution. So, off we go. Okay, so that is the end of the one variable equations. Next, two variables. Two variable equations, typically x and y. Yeah, so something like this, you know, x plus y is equal to 5. In a two-variable equation, you're always going to have an infinite number of solutions. There are always an infinite number of ordered pairs, x and y, as we were talking about yesterday, or you might be watching this all on the same day, but in 2.1, ordered pairs are a pair of numbers, x and y, which satisfy the equation. Yeah. For example, 2 plus 3 is equal to 5. So that would be the ordered pair 2, 3. Yeah. X is 2, y is 3. Yeah. But 3 plus 2 is also equal to 5. So that would be the ordered pair 3, 2. This time x is 3 and y is 2. And I could actually sit here all day making up solutions to this equation if I wanted to. 1 plus 4 is equal to 5. So you're always going to get an infinite number of pairs that add to be whatever it is in the particular equation. So we have 1 plus 4 is equal to 5. Remember, I'm looking for the x and the y. You can kind of match them up. The order does matter. So I've got 1, 4. And I'm going to stop now. I'm just going to say, et cetera, et cetera, et cetera. You could sit here all day making up equations, making up solutions. So you have 0 plus 5. That would be an answer. Or you could even use negatives. Yeah, maybe I'll do one more. Negative 1 plus 6 is equal to 5. Yeah, that would be negative 1 and 6. Okay. So the solutions are the ordered pairs. These are the solutions. Every single possible pair of x's and y's has to be in that order, x and y, that in this particular example add up to be 5. So what does it look like? What does this solution look like? I'd like to actually see a visual representation of what these answers actually look like. And that's where we're going to go back to the graphing that we were doing yesterday. X and Y, the rectangular Cartesian coordinate plane, Cartesian coordinate system. Each one of these points is a dot. Let's go ahead and plot a few of them. -1 and 6. Yeah. Let's see. Let's go in order here. 1 and 4. 1 and 4. Let's go to 2 and 3. 2 and 3. And 3 and 2. I know I should probably be using my grid, but I'm not. This is really just the warm-up problem anyway, so we'll get to the meat of it in a second. And so this is a graph of the solutions to the equation x plus y is equal to 5. So this is what we're going to be doing in the rest of the examples for 2.2. I'm really just using this as an introduction, so let's go ahead and get into the material. Example 6. Graph 2x plus 6y minus 12 equals 0. Now, by the way, I often will just say graph when I really mean graph the solutions. That's really what we mean. But we often just say the word graph when we actually mean the solutions. I mean, you wouldn't graph something that was not a solution, right? You're only graphing something that actually satisfies the equation. So, all right, so we have a two-variable equation. This one's a little bit different. It says 2x plus 6y minus 12 equals 0. Okay. We're going to go ahead and rewrite this a little bit. I like to move the 12 over to the other side. Okay. Now, this is what we call standard form. Standard form is a little bit more difficult to work with because you're basically guessing, right? I mean, you would have to guess some numbers that add up to be 12, essentially. And it's not as simple as the last one where you just say 2 plus 3 and 1 plus 4 and things like that. You'd have to do combinations of this that add up to be 12, all right? So here's what I recommend doing. Only guess one of the numbers, not both. I mean, last time we were guessing both, 2 and 3, 1 and 4, something like that. That's very difficult as the problems get more complicated. So you can start by just guessing one number. I usually say start with 0. Yeah? This is what you call an intercept. We mentioned this a little bit yesterday. If you have a 0 in one or both of the spots, that is called an intercept. Now, you don't want to put 0 in both spots. Just put a 0. You can put it in either one. I'll probably do the other one in a minute. And we'll see what the other one comes out to be. Okay? So this is the way it works. You guess a number. I usually start with 0, but you can pick any number you want. I recommend starting with 0. Plug it in and see what happens. So plug that 0 in here for x. So notice your x is now 0 here. 0 is a wonderful number in mathematics because it kills everything it touches. Yeah? So 2 times 0 is gone. So we don't write it. 2 times 0 is 0. 0 is invisible. We don't write it. So really our equation is 6y equals 12. This is why we just learned the one variable equations. Because now you can see how to do it. 12 divided by 6 is 2. Come over here, and now I have an ordered pair, 0, 2. Zero, comma 2. All right. For a linear equation, you have to graph at least 2 points. At least. All right. I'll probably do 3, but at least 2. The first 2 points are going to be very easy. Start with 0 for x and figure out what y is, and then reverse it. Put 0 for y, and then figure out who x is. I am running out of space here, so I'm going to have to go over here. So now I'm doing the 0 for y here. So now I have 2x plus 6 times 0 equals 12. Equals 12. So now I have 2x equals 12, right? I don't have to write this anymore. It's 0. If you want to put plus 0, you can. But I'm getting low on space, so I'm not going to do that. And now I'm going to divide both sides by 2, and I get x equals 6. All right, the ordered pair would be 6, comma 0. Okay. That's enough. I said I was going to do 3. I'm just going to do 2. I will do 3 if it becomes necessary. This is example 5, right? So it's not quite necessary yet. Maybe in example 6 or something like that, I'll have to do a third point. All right, so I asked you to graph it. So let's go ahead and do our graphing board here. So we've got, let's go ahead and do it this way. So I need you to graph 2 points. So we're going to go 0, 2. So that'll be right here. You can also just put the number 2 on the axis, and that would mean the same thing. And then 1, 2, 3, 4, 5, 6, 6, 0. Or you could also just mark that off as the number 6. All right. I like you to understand the ordered pairs, and I'm going to talk about these, what they mean in a minute. All right, and there you go. That's your graph. On the computer, there is a tool for graphing. It's pretty clear. It looks like a line with 2 dots on it, and so as soon as you click on those 2 dots, the line will automatically appear through the 2 dots. Okay. You don't have to worry about using a ruler or anything like that. I know mine's not very straight, but you get the idea. Okay, so this is the graph of the solutions to the equation 2x plus 6y equals 12. This is what we call standard form. Before we put this to rest, I'm going to use this graph to teach you the next form, the form that we're going to use the most often. So technically we are done with that example, but I want to teach you another form. It's called slope-intercept form. That's the next form we're going to learn about. So slope-intercept form is y equals mx plus b. M is called the slope. And b is called the y-intercept. So you have to make sure you pick the right y-intercept. Don't pick the x-intercept, pick the y-intercept. In other words, the point that is on the y-axis is the y-intercept. And so B is the second coordinate of the y-intercept. All right, so B is always the second coordinate of the y-intercept. So 0, 2, that means B is 2. All right. Now the slope is a little trickier. The slope is the rise over the run. Yeah. Or the change in y values divided by the change in x values. And I typically use the intercepts to figure that out, but sometimes that won't be possible, but it's possible in this case, so we're going to go ahead and do it. You draw a little triangle here, and this is called the rise, or the change in y, and this is called the run, the change in x. I want to be careful with the word rise. When something is going down, it is still rising. It's going down. Down 2 units. Yeah, you're starting at this point and you're going down 2 units. And then the run is going to the right 6 units. So when I do my slope, it's -2, +6. Yeah, down is negative, right is positive. So that is -1/3. You have to reduce it. 2 divided by 6 is 1/3, so -1/3. I typically just put the negative up top, but you can also put it out in front like that if you like. Just make sure you have the negative sign there somewhere. Okay, and so that gives us our slope-intercept form. This is your M. Your M is -1/3. This is your B, which is 2. And so the answer for slope-intercept form is -1/3 x plus 2. So you have your slope is -1/3, and your y-intercept is 0, 2. All right, that's it for example 5. Example 6. Find the slope and the y-intercept. You do not need to graph. I mean, you can graph it if you want. I'm not going to give you any extra credit for graphing it, but I mean, you can do it if you want. Let me give you an equation, and I ask you to find the slope and the y-intercept. -3x plus 5y is equal to 10. This is not in the right form. Yeah. This is in standard form. You need to rewrite into y equals mx plus b, slope-intercept form. All you have to do is take this equation and manipulate it into the form that we just saw in the last example. All right. So we'll go ahead and do that. We're going to add, let me just bring this whole thing down. We're going to add 3x to both sides. Make sure you don't accidentally write 10 plus 3x. You want to write it in the standard or the slope-intercept form. So notice the x comes first, and then the 10 goes last. And then now here's the tricky part. You have to divide everybody individually by 5, or whatever number happens to be in front of the y. That's your coefficient, we call it, the coefficient. All right, we got it. So there's our form. We got y equals, notice 5 and 5 just become 1. That's 1y. And you got 3/5. 3/5 is not reducible, so I'm just leaving it alone. And then x. Make sure you don't accidentally put the x in the bottom. The very first thing I said in this lesson is the variable cannot be in the bottom. So put it on the top or off to the side. And then 10 divided by 5 is 2 again. Oh, man, me and my 2's, yeah? And so now I didn't ask you to graph it, but I did ask for the slope and the y-intercept. Let me go and put my answers over here. Slope is 3/5. Y-intercept 0, 2. Yeah, equals 0, 2 or something. Now, when you're talking to your friends, well, you can say the intercept is 2. That's fine. But when you're talking to me or when you're putting in your answer in the computer, you have to say it the right way. It is 0, 2. Honestly, I didn't plan it to be the same 2 as last time, but it just came out coincidentally to be 2. Let's go the other way. I always teach questions like a coin, right? I want you to know heads, but I also want you to know tails of the same coin, right? So now we're going to flip it over and look at the tail side of the same coin. Find the equation in slope-intercept form of the line. I'm not sure if I mentioned this. Maybe I thought it was obvious, or maybe I just forgot to mention it, but the word line comes from linea, which is linear. So it's linea, linear, line. So when I say line, linear, those are synonyms. They mean the same thing. With slope, let's do m equals -6. Passing through the point -1, -7. All right. So we need to start off with a template. So we have slope-intercept form. That tells us to use y equals mx plus b, slope-intercept form. And you know that your slope is -6. You know that your x is -1. And you know that your y is -7. Now be careful. In slope-intercept form, it's reverse alphabetical. So the y is on the left-hand side. That's -7. And then the x is on the right-hand side. We don't know what b is. B is the unknown value. Now, with whole numbers, I wouldn't really worry too much about the parentheses. I would probably just use like a dot or something for times. But with negative numbers, I always use parentheses, because otherwise that's going to look like 6 minus 1, or negative 6 minus 1, or something like that. Negative 6 and negative 1 is 6. Negative times a negative is a positive. Yeah. And then now you're trying to solve for b, figure out what b is. So we are going to add negative 6 to both sides. Some people call this subtracting 6. I say add, because if you're adding, negative plus a negative is another negative. Yeah, negative, negative is a negative. You're adding them. You're not multiplying them. You're not really subtracting either. You're adding more negatives. So b is going to come out to be negative 13. So that means your y-intercept is 0, negative 13. Now we're basically done. The problem says find the equation. Let's go back and read the question again. Find the equation. This is the equation, so my answer is y equals, right? I got to put it back into the equation form. I know my m, negative 6x, and I know my b, plus negative 13. I'm using the parentheses because that's negative. You can type it in this way. It looks funny, but it's correct. I like to get rid of the parentheses by multiplying. Yeah, this is a positive times a negative. So that's just going to be a negative 13. This is the more traditional way of answering it. However, if you left it as plus a negative, it's still correct. It just looks funny. Yeah. It's awkward, but still correct. Before I do the next example, I want to talk about the 3 different forms. Forms, 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 and more forms. Yeah. A form is a mold or a template. Yeah, it's like a design of a line. In this particular case, we're talking about lines, but forms are going to go all throughout mathematics and throughout this course. The first form is called standard. Standard form is ax plus by is equal to c. That's the form that a lot of problems are given in. Yeah, not very useful. They're a real pain to work with. You have to basically guess a number and then plug it in and solve it, and there's a lot of work to it. That's why it's called standard. I don't know if you remember when cars had stick shifts. Not very many cars have stick shifts anymore, but another name for a stick shift is a standard. Yeah, you have to do a lot of work to drive a standard. I don't know if you remember when you're 15, 16 years old, if you tried to drive a standard, it wasn't very easy. Then we have another form that's kind of like an automatic. Slope-intercept form is much easier. I don't know if you noticed in the last 2 examples, this y equals mx plus b form is much easier. I intentionally use a different case. Capital B is not the same as lowercase b. They're different. They mean different things. Yeah. You can take standard form and you can rewrite it into slope-intercept form. I recommend doing that. Whenever somebody gives you a problem in standard form, you can rewrite it into slope-intercept form. Well, we have a third form called point slope form. Point slope form you can also rewrite into slope-intercept. So if you have standard, you want to rewrite it into slope-intercept. If you have point slope, you are going to rewrite it into slope-intercept. So your goal is always going to be to write your equations in slope-intercept form. Point slope uses subscripts for any point x1, y1. You can use any point that you like. Let's do an example of point slope. Find the equation of the line passing through -4 and 2 with a slope of m equals 1/2. M equals 1/2. I'm going to ask for two things. I'm going to say write your answer in point slope. We'll call that, I guess, A. And then B, write in slope-intercept. Rarely ever do I ask for standard. All right, you'll see standard, but I rarely ever ask for it, at least not at this particular time. Okay. So here you have your slope, m, and you've got your point, -4 and 2. So let's go ahead and label everybody. Well, this one's already labeled m. I'm being really nice by using the letter m here. Sometimes I won't say that, and you would just have to know in your mind that this is m. Yeah. So just keep that in mind. Sometimes I will just say the slope, but I won't say m. In fact, that's going to happen pretty soon. And then I'm going to say passing through. The first coordinate is called x sub 1, subscript 1, and the second coordinate is y subscript 1. So x1, y1. We'll start off with our point slope. Y minus y1 equals mx minus x1. All you have to do is take these ingredients and put them into your recipe. Just put them all in. All right, so here we got y. My black pen is finally dead. So we're going to switch all to blue here. Y minus 2 equals 1/2. M is 1/2. X minus, now be really careful with negatives. We learned about this yesterday. When you plug in a negative, put parentheses around it because those two negatives are going to turn positive. And you can stop. Part A is done. All right, so that is the answer for part A. Y minus 2 equals 1/2, parentheses x plus 4. All right. To do part B, you're simply going to take the answer from part A and rewrite it into the y equals mx plus b form. I'm just going to copy the whole thing and start from there. Y minus 2 equals 1/2 x plus 4. Make sure you copy it correctly. And now I'm going to rewrite it. First, we use the distributive property. Be careful with fractions. That's 1/2 x. Don't put the x on the bottom. It should be, your choice is either to put it up top. Looks kind of funny when you put it up top, or put it off to the side. Do not put it down with the 2. It'll mark it wrong. I'll have to mark it wrong. Okay. And then now plus 2 on both sides. Remember, your goal is to get y by itself. And so the answer for part B, slope-intercept form, is 1/2 x plus 4. It's a coincidence that that was a 4, and then when you got done with it, it stayed a 4. That, oh my good, I wish that didn't happen, because those types of coincidences sometimes lead you astray. But I just took the problem right off the computer. I mean, I'm grabbing random problems just like you'll get random problems on your homework. So. Okay. What are we up to? Example 8. Special cases. There are 2 types of lines that are special cases. Come on back to me. Come on back to me. There we go. Sometimes I can't tell if that's my glasses or if that's the camera, so let's give it a second to come back. Come on back. Come on back. Come on back. Focus. There we go. Special cases, vertical lines. Vertical lines only have an x and a number. All right. The slope is undefined. Yeah. Undefined. Some people call it no slope, but I don't like to say no slope because that sounds like 0. But we like to say undefined. All right. The symbol for undefined throughout this course is DNE, we call that. Does not exist. It means that if you were to look it up and try to find the actual slope, it would just not exist. All right. So there's your special case number 1. And special case number 2, horizontal lines. Lines that go horizontally, y equals b. And b is, of course, a number. So basically, these are special cases of equations that say either x equals a number or maybe y equals a number. And if you see one of these, I want you to know that they are special. Vertical lines, the slope is DNE, undefined, does not exist. For a horizontal line, the slope is 0. M equals 0. You don't even see an M, right? You don't see it. So that means it's 0. It means it's horizontal. So remember, vertical lines go like this, vertically, up and down. Horizontal lines go horizontally from side to side. All right. Easy way to remember that, the horizon. Yeah. Go out of your house and look east. You're going to see a flat horizon. You might see a few little mountains out there, but basically as you look east, you're going to see a flat line. Or go to the beach and look west, and you're going to see the ocean. It's going to be horizontal. It's going to look like a flat line. Although we all know it's not really flat, but it looks flat. That's where we get the word horizontal from, horizon. These are very special cases. They don't occur very often. I put them out there because if you run across them and you try to use the other methods that I taught you, those methods are not going to work. So you have to know that these are special. Special cases require special handling. You have to handle them special. All right. Let's do an example of these. Example 8. Find the equation of the line, of the vertical line passing through -8 and -4. Okay. Let's draw a quick graph just so you get the idea. Try that again. So I got X, I got Y. I don't need to be very precise. Remember, I was calling this freehand. So you've got the point -8, -4. Right? -8 is X, -4 is Y. Vertical line. Vertical goes this way, up and down. That's vertical. Sorry, I wiped out my -8 there. That was -8. And so the way we read this, X is always equal to -8. Yeah. Think about it. At this point, what's X? Well, it's -8. What about down here? You know, suppose Y was, let's go down here, -6 or something. Yeah? I know, it's hard to see that. That's 6. Well, I'm not asking about Y, I'm asking about X. X is still -8. Yeah. What about right here? Yeah. Well, Y is 0, but what's X? X is still -8. Yeah. If you wrote them out as pairs, it would be -8, 0, -8, 4, -4, -8, -6. Yeah. You could even go up here to like 2 or something, right? Right here, what's X? Well, it's still -8. Yeah. So notice X is always equal to -8. So the equation, question says find the equation, and that's it. Done. The slope does not exist. It's a vertical line. The slope does not exist. If you tried to calculate the slope, you would get an error. You get a DNE, does not exist. Right? One way to see that is that there is no run. Yeah? It's all rise and no run. Yeah? If you have no run, that means you're dividing by 0, and that means that the slope would be DNE. Okay, so there's your answer. X equals -8. You might be tempted to just memorize it. Vertical line, take the X coordinate, and you're done. Yeah. Now, you might not know whether you're getting it right, so by drawing the picture, you get a better idea of what's going on. Okay. Let's try a horizontal one. Might as well, huh? I'll tell you what, it is kind of buy one, get one free. If you memorize vertical, you'll get horizontal for free. So find the equation of the horizontal line. Passing through -2, 6. So find the equation of the horizontal line. You see that? Yeah, horizontal line passing through -2 and 6. Remember, horizontal line comes from the word horizon, so it's horizontal. It goes like this. So you have -2 and 6. And so every point on this line, y is always equal to 6. Every point, yeah? This point is -2, 6. This point here is 0, 6. This point here would be +2 and 6, you know, 4, 3, 4, 5, 6. This point here would be 6 and 6. But notice in all of these points, y is always equal to 6. It's a horizontal line. So you just say y equals 6. The slope of a horizontal line is all run and no rise. Yeah? So the numerator, the rise is 0. So that's the reason why this has a slope of 0. This would be the same as y equals 0x plus 6. I'm going to put that in a bubble just so that for your notes, the slope is 0. Yeah, m equals 0. That's just for your notes. The actual answer in the computer is y equals 6, yeah, for this type of problem. You might get a different number in your problem, but nonetheless, there it is. Okay, kids, we have come to the end. We got one more example. This is what I call the worst case scenario. The worst case scenario is where I only give you points. That's it. I don't give you any other information. I just give you points. And you're going to determine everything from those points. And that ought to do it. Example 10. Find the equation of the line. Now this line's not a special case. It just says the line. It's not horizontal nor vertical. So you have to just work it out. Passing through the point -1, -7, and 5, 5. So this is the worst case scenario. Because I'm basically just giving you 2 points, and you have to do everything else. Let's see, maybe I'll go this way, it'll fit better. So let's see. So I've got -1, -7. There. And I'm just going to leave that as my label so this doesn't get too messy. And then 5, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So right there, 5, 5. If you want, you can label them A and B like we were doing in the last section. I think that just adds more letters and it makes it more complicated. So we're looking for this line here. So we need to find the slope. The slope is the change in y divided by the change in x. The symbol for change is subtraction. Yeah, think about it. You go to the store, you buy something for $15, you give them a $20 bill. What's your change? Your change is 20 minus 15, which is 5. So change is subtraction. So you're going to go y values, y2 minus y1. That's the change in y. X values, x2 minus x1. Oops, I almost got that wrong. x1. And you're going to take your x1 and your y1 from up here, and your x2 and your y2 from up here. Remember in the 2.1 section, I just said whatever the first pair is, that's x1, y1. Whatever the second pair is, that's x2, y2. Don't really worry too much about it. Just don't mix up your letters x and y. So this is going to tell us the slope of this line. It's the rise, it's going up, and it's going over. That's the run. Okay, so the rise and the run. So how far is it rising? Let's see, 5 minus -7. And that's the y2 and the y1. And then the x2. 5 minus -1. So you're going to get 5 plus 7 and 5 plus 1. So you're going to get 12 over 6. And so the slope is 2. The slope is 2. So it's rising 12. That's positive 12. It's going up 12. And it's running positive 6. So it's 12 divided by 6. That's your rise over run. And you have to simplify it. 12 divided by 6 comes out to be 2. So the slope of this line is 2. All right. I really didn't need the picture to solve it. I could have solved it without the picture. But I like to see the picture and how it corresponds to the slope. The graph should look reasonable. And you can also find, if you make a small mistake, one way to capture your mistake and edit it quickly before it gets you is to draw the picture. All right. Once I know the slope, then I throw away the x2, y2, and I only use the x1, y1. And now I do my point slope formula. Yeah, or you could try one of the other formulas, but I guarantee this one's going to be easier. All right. So y minus negative 7, that's my y1, equals m. I take my m from over here, that's 2. X minus, remember, be really careful with negatives, x minus negative 1. So I have y plus 7 equals 2 times x plus 1. Remember your negatives. And you're going to get 2x plus 2 when you distribute. And finally, you want to get your y by itself. So subtract 7 from both sides. And your final answer is y equals 2x minus 5. Okay, that was section 2.2. We did not have time today to cover parallel and perpendicular lines. So you might notice a couple omissions on the homework. I don't know. We'll see what that gets to later. But this section is now done. I'm just going to go ahead and call it here. 2.2 is complete. Dr. Jordan signing out. See you next time on the internet.